Hi, welcome back to the second of our two lectures in object-oriented programming. We're really just getting you started here. You'll have lots of opportunity to explore how object-oriented programming works and getting more experience with it yourself as you complete the programming assignments for the rest of the semester. We're going to start with a review of some of the code we developed last time, and I'm going to pose a series of questions. Before going on and listening to the answers, you might find it useful to sort of stop and think about what you would answer if you had to. By way of review, let's look at the code from last time. This code introduces 5 new classes, 5 new user-defined types into the Python system. We have a class of type person, and then this are the methods and other attributes of the person class. A subclass of person called MIT person, and here are its methods and attributes. A subclass of MIT person called student, and finally 2 subclasses of students called undergraduate and graduate. So when we use the name of a class, in this case student, and use it like a procedure call, in this case by passing an argument, the string Tim Beaver, what Python does is it creates a new object of type student and then calls the init method for that object with this argument. So let's see if we can figure out what happens. So we have an object of type student, and we're looking for its init method. So student itself defines no new methods. So we look at the superclass of student, which is MIT person, and we see that it does, in fact, define an init method. So Python will call this method. The first argument for any method is the object that's being manipulated, in this case the newly created object of type student, and the second argument is the string Tim Beaver. So what the MIT person init method does is the first thing it does is it calls the init method of its superclass person, and it passes along the object that we're trying to initialize and of course the argument Tim Beaver. The init method for person adds 3 new instance variables: name, birthday, and last name. And when it returns, the MIT person's init method defines an additional instance variable called IDnum. And what it puts into IDnum, it uses a class variable, in this case nextIDnum, which is one of the data attributes of MIT person. It takes its current value and makes that the ID number for the newly created object. And then it goes off and increments the class variable so that the next object of type MIT person that gets created will have a new and unique ID number. That object then gets returned, the initialized object then gets returned as the value of the constructor, and that becomes then the value of the mascot variable. So if we ask what mascot is, it's an object of type student, and it has 4 instance variables: name, birthday, last name, and IDnum. So what does this do? Mascot.getLastName, a procedure call. So the dot, remind ourselves, is the sort of attribute operator. What we'd like to do is to get the getLastName attribute of the mascot object and then call it as a procedure. So we need to figure out how Python does that. So Python first looks at the instance variables of the object to see if in fact there is an attribute called getLastName. And the instance variables are name, birthday, last name, and IDnum. So no, they didn't provide a definition for getLastName. So now we look at the class definitions. Student doesn't provide a definition for getLastName, nor does MIT person, but the base class in the hierarchy in fact does, and here's the definition. So Python will then call this method, passing in the object that we're manipulating, in this case the value of the mascot variable, which is an object of type student, and that object does in fact have a last name instance variable, and we just reach in and grab it and return that as the result of mascot.getLastName. Suppose we want to sort a list of people. What order will the list be sorted in? Well, we have to understand a little bit about how Python does sorting. A sort algorithm uses the less than operator to determine the relative ordering of 2 objects, and then it has an algorithm to try to minimize the number of comparisons it makes in order to put the list in the correct order. We can actually define what the less than operator does on an object by creating a definition of the less than special method. So remember, special methods start with a double underscore and end with an underscore in their name. So here's the definition of less than for a person object, and so we have an object that appeared on the left-hand side of a less than operator, and now the other object, whatever it was on the right-hand side of the less than operator, is passed in to this method call. So self is the object on the left-hand side, and other is the object on the right-hand side of the comparison. And let's see what it does. It basically checks to see if the last name of the two person objects is the same, and if so, it uses the whole name to sort. So it compares the whole name, so it's doing a lexicographic comparison, a string comparison on the two name strings. If the last names aren't the same, it basically just sorts them by last name. So what this code boils down to is if you have the same last name, you're sorted by your first name, or your whole name, and otherwise you're sorted by just your last name, if the last names are different. Okay, so that's how persons are sorted when they're sorting. Suppose I had a list of students and I'm trying to sort them. Well, let's see what sort of less than operator we have defined for students. Student doesn't define a less than operator, but MIT person does. And we can see that the MIT person definition of less than overrides the definition that occurred in person. So if I try to sort an MIT person, student, an undergraduate, or grad, I will discover that this is the operator that Python will find when it does the sort. And that operator, basically, the comparison it does is by ID number, not by last name. So students are sorted by ID number, and but a list of people would be sorted by their names. So why do we introduce the empty class student? It defines no new attributes. It seems like, couldn't undergraduate have just been a subclass of MIT person? What was the advantage of introducing this sort of placeholder in the hierarchy? And the advantage is that we get to use the name student as sort of a collective noun for all the different types of students, all the different subclasses of the student class. So it's very easy for us to determine whether a particular object is a student or not, because we can basically ask if it's an instance of type student. Otherwise, what we'd have to do is to sort of ask, is it an undergraduate, is it a graduate? So the introduction of this type hierarchy often provides us convenient handles for dealing with collections of types. Finally, let's ask what the substitution principle is. And this is really an important part of object-oriented programming, sort of the power of what makes object-oriented programming work well. So the substitution principle basically tells us that any subclass of type person should pretty much also behave as a person. So we want to inherit a lot of behaviors of the person object when we create subclasses. So in particular, for example, we would expect students to behave as people for any code that was written to deal with people. So, for example, if we had bought somewhere from Hallmark cards a program that would every day send out birthday cards to people whose birthday it was, and it would take a big list of people and look at their birthday and do the right thing, we would want to make sure that that would work just fine on a list of students. So we don't want to redefine what birthday means in any of the subclasses, because that would break the behavior of this program that manipulated people. So just to say it again, so the substitution principle tells us that any subclass of the type person should also be able to be used in any context that a person could be used in.